Okay, so now I will be discussing about inverse functions. Now, before I explain what an inverse function is, I want to first discuss about a one-to-one function and a many-to-one function. So now, from the definition of a function itself, we know that if we have some sort of function f, and I consider an input that is in the domain of f, so let's say I have some value of x, and I input it into this function, then I should get a single corresponding output f of x, right? So we know that for a single input of x, we should get a single corresponding output y. So for one value of x, I should get some value y, right? But that is not to say that for multiple values of x, I can still get the same exact output. So let's say if I consider inputs x1 and x2, it is possible for me to still get the exact same output, say y1, right? We can have multiple values of x that correspond to exactly the same output. And that will still satisfy the definition of a function, because at the end of the day, each of these inputs are still corresponding to exactly one output, right? So we can take a look at an example of a function like this. So let's say we have f of x to be equal to x squared, right? So now let's say that our output for this function happens to be 4, right? So we can see that if our output is equal to 4, then my corresponding inputs could possibly be x is equal to 2 or x is equal to minus 2, right? And we can check this. We can show that for f of 2, we get 2 squared, which is 4. For f of minus 2, we get minus 2 squared, which is also equal to 4, right? So when we have multiple values of x giving us the exact same output, this is known as a many-to-one function. So this is a many-to-one function. Once again, this still satisfies the definition of a function because each of these inputs are still giving us only one output, right? And we can use sets to explain this. We can have, say, this is this domain which has elements x1, x2, x3, for example, and we can have the set of range for the function f of x, and we have y1, y2, y3. Now it is possible for x1 to correspond to y1, x2 to also correspond to y1, and x3 may be corresponding to something else, maybe y3, right? This is the definition of a many-to-one function. Now, similarly, well, not similarly, a one-to-one function is when each value of x in the domain of a function f corresponds to a single unique output, right? So if we have a value of x, we have a unique value of y, right? So, for example, if I have the set of domain and a range for a function that is one-to-one, then if I have the inputs x1, x2, x3, and if I have y1, y2, y3, right, or y4 even, then each of these inputs, they correspond to a unique output. So multiple values of x cannot correspond to the exact same value in the range, right? So each element in the domain corresponds to a unique element in the range, and each element in the range corresponds to a unique element in the domain. So x1 corresponds to y1, x2 may correspond to y3, x3 may correspond to y2, but we can never have x1 and x2 both corresponding to y1. So that is the definition of a one-to-one function. Right, so since we have now discussed the concept of a one-to-one function and a many-to-one function, we can now talk about an inverse function, right? So for an inverse function, only one-to-one functions can have an inverse function. So let's say I have a function f, and this is a 1-to-1 function, right? So this means that we know that for each value of x, we have a unique value of y. And for each value of y, we have a unique value of x. So an inverse function is just the correspondence from the range of f, of the function f, back to the domain of f. And this correspondence is known as the inverse function. And we can denote the inverse function as f inverse of x, right? So this is the inverse function, right? Not to confuse this with f to the power of -1 of x. This is not the same as 1 by f of x. This is just denoting the inverse function, nothing else, right? These two things are not the same. So once again, there is exactly one value of y in the range of f. For each y that is in the range, there is exactly one x in the domain. So from this, we can see that only a 1-to-1 function can have an inverse function, right? Because if we consider, say, okay, we have f of x is equal to 2x plus 4, right? So we know that for each value of x, we have some unique value of y. If I have x is to be equal to 2, then f of 2 is equal to 4 plus 4, we have 8, right? So f of 2 will be 8, right? And I know that there isn't another value of x which will give us 8. Only x is equal to 2 gives us 8, right? So if I find the inverse function of this, right, then all I would do is I would take 8 as an input into this function. So I would have f inverse of 8, and this will give us 2, right? So I just went from the range of the function f back to the domain of the function f, right? So if I have f of a to be equals to b, then the inverse function will take the output of our function f as an input and give us the input of the function f as an output, right? So it's just going from the range of the function f back to the domain of f, right? So we can see that for each of these outputs, we have a single input, right? But if we considered a many-to-one function instead, if we considered a many-to-one function, right? Then in this case, once again, if I have f of x is equal to x squared, and for x is equal to 2, I know that y is equal to 4, or f of x is equal to 4, right? Then if I find the inverse function of x, and I take my output of function f as an input into the inverse function, then f inverse of 4 will give us what value exactly? Will it give me 2 or -2, right? So we can see that for the input 4, this corresponds to two output values. We can have a 2 or a -2, right? And that defies the definition of a function. We're taking a single input, but we're getting two outputs, and this does not satisfy the definition of a function. Therefore, a many-to-one function does not have an inverse function, right? Now, from this, say we have some function g, and g is the inverse of function f, right? So if we have some value of x that is in the domain of f, then we will get some output f of x, right? So f of x will be defined. And from this, we can show that g of f of x should be equal to x, right? If I have some x that I input into my function f, I will get the output f of x. And if I input this output into my function g, I should just get the very first input that we began with, which is x, right? And this is for all values of x in domain of f. So for all values of x in the domain of f. And similarly, f of g of x should also equal to x for all values of x that is in the domain of g. So if g is the inverse of f, well, if g is the inverse of f, then similarly, the function f will also be the inverse of g. So once again, if I have a function f of x, I can denote the inverse function as f inverse of x, and the domain of the function f will be equal to the range of the inverse function. And similarly, the range of our function f will be equal to the domain of our inverse function. And we know this because of the correspondence from the range of function f back to the domain of f, right? And if I have a function which has an inverse, then this inverse function is unique, right? So for one function, we cannot have two different inverse functions. This is the only inverse function that we can have for f of x. Okay, so now let's consider some function f of x that is equal to 3x minus 5, right? Now let's suppose that a function g is the inverse of the function f, right? Then we should know that g of f of x is equal to x, and similarly f of g of x is also equal to x, right? So now we can find the inverse function of f. Since we know f of x, we can try and find f of g of x, right? So we want to find the inverse function g of x, and this g of x is our input right now into the function f. So I have 3 times g of x minus 5, and this should be equal to x, which we can see from here. And that is because these two are inverses of each other, right? So now we can just solve this equation for g of x. So we have g of x times 3 is equal to x plus 5, and we can just divide both sides by 3, and this gives us g of x is equal to x plus 5 divided by 3, right? And this is our inverse function. So g of x is the inverse of f of x. Now if this seems confusing, we can also just let f of y, so we can just let alternatively f of y to be equal to x, right? So for f of y, we have 3y minus 5, and this is equal to x. And now we can just solve this equation for y, right? So once again, we have 3y is equal to x plus 5, divide both sides by 3, we get y is equal to x plus 5 by 3. And y is our inverse function of f. So f inverse of x is actually equal to this, right? Okay, so now let's take a look at another function. We have f of x, and let's say this is equal to minus 5 minus x divided by 3 minus 2x. So now I want to find, so let's say that we are asked to find the f inverse of 7, but without, without finding the inverse function itself, right? So once again, we know that f of f inverse of x should give us x. So if we let y to be equal to f inverse of 7, and we're just doing this for simplicity, it's easier to work with just y instead of writing f inverse of 7 all the time. So if we let y to be equal to f inverse of 7, then we see that f of f inverse of 7 should be equal to x. Sorry, it should be equal to 7, right? And we can see this from this, right? So in this case, we're considering x to be equal to 7, so we should just get x back, right? And this is just f of y is equal to 7. So we can find f of y, which is just minus 5 minus y over 3 minus 2y. All we did is just replace the x here with y, because we're considering y to be the input now, right? So f of y is equal to this, which is equal to 7, which we see from this. Right. So now we can just solve this equation for y. So we can just rearrange, multiply both sides by 3 minus 2y. So we have minus 5 minus y is equals to 7 times 3 minus 2y. Right, so we have minus 5 minus y is equals to 21 minus 14y. Bring the 14 to the left side. So we have 14y minus y. We have 13y. Oops. So we have 13y is equal to 21 plus 5, which is just 26. And then we can divide both sides by 13. So we have y is equal to 2. So this is our value of y. Right, so that means f inverse of 7 should be equal to 2. And we can check our answer by just substituting this value into our function. So if we have f of 2, we can see that, well, so for f of 2, you have minus 5 minus 2 over 3 minus 2 times 2. Right, so this is minus 7 divided by 3 minus 4, which is minus 1. This gives us 7. So we have f of 2 is equal to 7. Right. Now, once again, working with the same function, we had f of x is equal to minus 5 minus x over 3 minus 2x. Right, so now we just want to find directly the inverse function. Right, so we just want to find the inverse function. So we can once again let f of y to be equal to x. Right, so f of y is equal to minus 5 minus y over 3 minus 2y, and this is equal to x. So similar to the last question, just multiply both sides by 3 minus 2y. So this gives us 3x minus 2xy. So now we have minus y plus 2xy is equal to 3x plus 5. Right, and now we can just factor out a y. So we have y times 2x minus 1, which is equal to 3x plus 5. Divide both sides by 2x minus 1, and we get this. We get this equation, and this is just our inverse function. So f inverse of x is equal to 3x plus 5 over 2x minus 1. So this is our inverse function.